Hello and welcome to Leetcode Camp. I am Prasant and hope you're having a great day. First of all, I have started this video series to help fellow beginner and intermediate level programmers to crack their next coding interview. Mm, I'm going to be doing one problem every day, and I'm going to go in depth about the problem. I'm going to show the algorithm working behind it, and each of the algorithm is going to be important. Like you would be able to solve other similar problems with the algorithm, and before you know it, you're going to master your next job interview. So let's get started. The platform I'll be using is Leetcode. So if you're not familiar with Leetcode yet, it has a lot of coding problems related to data structures and algorithms. There's others, but I'll be focusing on data structure algorithms since those are the most important ones for now. And if you are able to solve at least 100 plus questions, then you would be pretty well off, and for if you're interviewing for top companies like Amazon or Facebook or Google, then you would probably need at least 200 plus questions in the very least. Like you could go more, but let's aim like our goal to be 100 days, so 100 problems, since I'll be solving one problem each day. The first algorithm I want to talk about, the easy, let's start with the easy algorithm. Let's look at binary search. So let it load for a bit. And so before I start, I just want to say you can choose any language that you want, like in the drop down. However, I'll be using Java since that is my primary language, but the logic is similar. You'll just need to implement it in your own language. So let's start. So what did it say? Given a sorted integer array, nums of n elements, and a target value, write a function to search target in nums. If target exists, then return its index, otherwise return -1. Okay, so in the first example, we have a number array, and then a target is given to us, which is 9, and it's told me the output is 4, right? Like it's told us. Why does it say that? Since it's going to look for the target, and the index of the target is, so since the first element is index 0, 1, 2, 3, 4, so 9 is at index 4, so the output is 4. Let's look at the second example. Same number array, target is 2, and 2 is not present anywhere in the array, so it's not going to return any index, but it's going to return -1 rather. So okay, it's fair enough. So I can think of two different ways to solve it. One of them is linear search, and then another one is, of course, binary search. This is a binary search problem, but linear search is the slower one. It's a naive solution, but linear search is basically where you would go from the first element of the array, and then you would go until the very end and then look for the number 9. So you're going to start from -1, then go to 0, then 3, 5, 9, and 9 matches the target 9, so you're going to return the index of the number. And if none of the elements in the array matches the target, then you're going to return -1, right? So that would be the linear search. I can implement the linear search quickly enough to, and so it does not take a lot of time. So for int, let's say each individual, actually let's say start from index 0 and less than nums.length, go till the end of the index. So for each of the number, if numbers I, if the number happens to be equal to target, then we're going to return the index of the number. But if the loop ends and there's no number to be found, then we're just going to return -1 at that point. So see how I'm putting it outside the for loop. And then let's try to run this code real quick. Leetcode gives you a lot of test cases, and if you pass, you're supposed to pass all of them so that your program is running perfectly. And let's try to submit it. So the test cases gave me has passed, and then it's passed all the test cases. But if you look at the runtime here, it says it's faster than 9% of Java Online submissions, which is pretty slow actually. I mean, this is linear search, right? So linear search runs in linear runtime. So since how do you calculate the runtime? If you look at this array, the worst case could potentially, like if you're trying to find the number 12, if your target was the number 12, then you would start from the first element and you would go all the way to the last element, right? So assuming there are n elements in the array, the runtime is going to be n in that case, which is the worst case. But even in the best case, if you are looking for -1 as the target, then it will be immediately found. So the best case is going to be a constant like O of 1 runtime, but somewhere in the middle is going to be somewhere like half of n, or like 1/3 of n, something like that. So it's going to be a fraction of n, which in programming we refer to that as a linear runtime. So overall, if the interviewer asks you what is the runtime of your linear search algorithm, if you implement it this way, then you're gonna say it's n runtime. And then if you are implementing it this way, I'm sure they're going to ask you, how can you optimize this better, which is like, this is not the most efficient algorithm. So you can say, yes, I can optimize the problem with using binary search. And let me explain to you what binary search is now. 3, 4, let's make an example array. 7, 8. All right, so we have an example array starting from 1 all the way to 8. Oh yeah, so keep in mind, binary search only works for sorted array. It's not going to work for an unsorted array. I'll tell you why. But for unsorted arrays, there are other like really good ways of solving them. But in the upcoming videos, I'm going to show you how to solve them too. But for now, this has to be a sorted array. So in a sorted array, if you are trying to, let's say you're trying to find the target is 6, right? So the 6 is present here. So if you are doing a linear search, you would start from 1, like from index 0, which is value 1, and you're going to go all the way, go to 2, 3, 4, 5, 6, and then you're going to find 6, and then you're going to return the index of the number. So linear search is slow, but binary search gets rid of half the array every time. Here, let me show you. So we're not going to be starting from the 0th index, we're going to be starting from the middle index. So if this array has the length of 8, right? So we're going to be starting from 4, like somewhere in the middle. So let's start from 4, and we're going to compare 4 with the target. Is 4 greater than 6 or less than 6 or equals to 6? It is less than 6, which means anything before 4, like, it's not relevant to us anymore. We don't need these numbers, so we don't need these numbers at this point. We're just going to be focusing on the other half of the array. So now, what is the middle value of this array? It's 6, right? Now we compare, is it less than 6 or greater than 6 or equals to the target 6? It is equal to the target 6, means the number is there, and we're just going to return the index of this value. Like, that's it. So binary search, all we needed to do was 2 searches. That's it. We search one time, and then we search one more, and that's it. So instead of having to search 6 times in this example, we just had to search 2 times. So the runtime for this is actually log of n. So if you have, let's say, like a million data, like an array of million data, I'm just gonna do ... If you have like an array of million datas, then in the first part you're going to go to the middle and then see if the middle is greater than the number or smaller than the number or equals to the number. If the number is less than the target, then you are going to get rid of everything like greater than the number, right? Like greater than the middle value, and you're going to look at 500,000 datas out of the million datas. You have cut the amount of data by half, and another step, again, you're going to cut the amount by half, and you keep doing that. So that's why it's log of n. Like, you're cutting every single like time, you're cutting the data by half. So it's in logarithmic time. And let's code the binary search at this point. I'm going to go through the coding section pretty fast because it's not really a difficult problem. It's actually one of a beginner level problem. So so let's see, we're going to need a left value, right, so that we can calculate the mid value. So let's start from the first index, which is 0, and then right value, let's start from nums.length -1. So that's the last index, so 6 minus 1, so 5th index, right? Since it starts from 0, we have to make sure the last index is 1 less than the length of the array. And then now we're going to be doing this, like we're going to be solving this problem iteratively. We're going to be how long are we going to doing this? Like we're going to end the loop when left happens to be less than or equals to right. So if the left becomes greater than right, then just close the program, or right, like if the left becomes greater than right, then just close the program, like close the loop, sorry. So until then you have to keep looping and just squeezing the left side, right side, just narrow it down to the field where if you can either you find the number, then you're good, it's just going to return the number. But if you don't find the number and the left becomes greater than the right, then you're going to return false, or you're going to return -1 for this problem. So while left is less than equals to right, if the number if the number array mid, which we have to specify mid. So let's say what is mid? Mid is going to be so we have right minus left divided by 2. So it would feel like mid is just like right minus left by 2, like this is all you would need for mid. But to avoid like buffer overflow, because for the first case it's going to work, but if you have an array somewhere in the middle starting from index 2 to index 4, if you look at the left, like I've highlighted that part, from index 2 to index 4 or something, then you have to add the left index with the right with the median so that you can reach the exact number. Because okay, let me tell you, like right here, so again same thing, like same array on the left. So -1 0 3 5 9 12. So let's say you're at the point where you're only looking at the numbers 3 and 5 and 9, right? Like the program, if you're looking at the number 3 5 and 9, so what is going to be your middle value? Your left value at this point is going to be the index of 3, which is index 2, right? Like 0 1 and 2. And then your right is going to be index so 3 is index 2, and then 9 is going to be index 4. So and then your middle value is supposed to be 5, right? So the index of 5 is 3, so your mid is supposed to be 3. However, if you just do right minus left divide by 2, then it's going to give you mid to be 4 minus 2 divided by 2 is going to be 1. So mid is going to be given 1. However, you need to add the left with the mean. So if you add left, which is 2, with the mean, then you're going to get 3, like that's your mid value. So I hope that makes sense. In the first case, right minus left by 2 will work, like in the very first iteration, but after that, when the left and the right index are shifted somewhere in the middle, at that point you need to make sure the left is here. So that's why I have the right minus left divided by 2. I have the mean incremented, I have the mean added to the left value so that we can get the middle value from that point, if that makes sense. I hope I'm being clear enough. Let's see. Okay, so we have the mid value now, and if the middle value happens to be equal to the target value, then we just return the index, right, which is the mid. Else if the middle value happens to be less than the target, then what do we do? So if the middle value happens to be less than the target, let's say if the middle value is 5 and it happens to be less than the target 9, then we're going to shift the left index from index 0 all the way to the mid, right? So we're going to shift the left index. Left is going to be mid, all the way to mid. But actually, so if the number mid was equal to the target, it was going to return that number, right? Like they return the index of that number. So we have already checked for the mid value, so we can just start from mid plus 1, like we can go 1 index upper than that. I hope that makes sense. And else, same thing here. So else, when in the case where number mid is greater than the target, then we're going to do right equals mid minus 1. We could start from mid, like we could have, but it would make more sense to start from mid minus 1. So cool. And then so whenever it finds the number, it's going to return the index of the number. But if the loop ends, the moment left becomes greater than the right, and if the loop ends, then we're going to return -1. So look here. So if the number is found in line 8, I've highlighted the line 8 too, like the numbers. So if the number is found, then you're going to return the index and the program terminates. Once you return something, the program will terminate. But if the number is not found and the loop is running and the loop ends, like there's no number, then at the end the program has no option but to return -1, since the program is asking for an integer return value. Which I hope that makes sense. Let's try to run the code and see if there's no errors. Yep, so the first test case passed. Now let's try to submit the problem. Cool. So runtime is 0 ms. Look at that. It's super fast. Like binary search is ridiculously fast. If you have a million datas, then you're cutting down half every time, and any number you wanted to find, you could find it in 8 or 9 iterations, like 2 to the however is 2 to the whatever number, 2 to the power whatever number is equal to a million. That's how much, because it's a log n, right? So you would be around probably like 17, 18, I don't know, like you have to calculate that, but in like 17 iterations you could search through 1 million elements. But if you're doing this in a linear search, then you would have to go through, in the worst case, all 1 million elements. So that is why binary search is very powerful, and you could get a lot of interview questions. Like you have the potential of getting interview questions that you could search with binary search. There are binary search trees. Like if you look at data structure trees, that is a very common question. So there are questions like validating binary search tree, if a tree is a binary search tree, and questions like that. There's a lot of like binary search tree related questions. I'm going to cover all of them in the upcoming videos, but I hope you're clear with this. What I want you to do is go through the examples again, like go through this array with the target, and then use the program and just run it through with a pen or pencil or something. Just start with left value, right value, and then while left is not equals to right, so the mid value is going to be 0 plus what is the size of this? Probably 6. Yep. So 6 6 means like right is going to be num-resultant -1, so 5 minus 0 divided by 2 is going to be 2. So start from the middle index, like second index, just run through the program for both the examples, and then I'm sure you're going to get a very good ideas. I could just do it for you too, but I mean, it's good brain exercise, at that point. So once you run through the program and once you understand the code, then I would want you to just go to Leetcode, and then without looking this problem, just solve it. Just go all the way, solve it, and try your best to solve it in one go. Like make sure you run through the program again, manually, do whatever, but before you press, you can do the run code as much as you want. Like just do the run code and make sure that the one test case is given to you is accepted. But before you submit, try to make sure it's taking into account all the edge cases and everything, and then go for submit. You could do like 4 or 5 submits. That's okay. You could do as much as you want in Leetcode, but on a for interview practices, like they are not gonna like it too much if you do a lot of submissions, or if you make a lot of edits and then say like my program is complete. Like it's not gonna be a good idea. So just try your best to use as little submits as you can, just for your own sake. So hopefully this series is working good. Like it's going to help you. Let me know in the comments if you like it, or if there's some things I have to improve, because this is just my first video. I'm just trying, just at this point, but hopefully I'll get better too with explaining the concepts. And let me know, like give me feedbacks, like what is not good or not, and please subscribe, because I'll be posting one video every day. So have a great rest of your day, and I'll see you tomorrow. Bye bye.